In the last two sections, we've been looking at the ANOVA, which tests to see if there is a difference in treatment means. However, it doesn't tell us which ones differ or by how much. It only tells us there is a difference or there is not a difference. So we would like to be able to rank the different means from smallest to largest and tell which differences are statistically significant. However, and one way we do that is by doing t-tests or hypothesis tests here. So in general, if there are k treatment means, then there's going to be k minus 1 over 2 pairs of treatments. So for k equals 6, this is going to give us 15 distinct pairs. So we could do 15 hypothesis tests. That's a lot of hypothesis tests to do. We'd like to find a more efficient procedure. So we want a method here that's going to rank the means and have an overall confidence level called the experiment-wise error that's at least as good here as any individual comparison. That's called the comparison-wise error. So the comparison-wise error rate is the probability of making a type 1 error in a single comparison of a pair of means. Whereas the experiment-wise error rate is the probability of making at least one type 1 error in multiple comparisons. So there's this idea of multiple comparisons. There's more than one way to conduct these tests. The methods that we'll consider are Tukey's test, which needs your sample sizes here to be equal. And then the other one that's widely used is the Bonferroni test. That does not require equal sample sizes. Both are going to produce a set of confidence intervals that are at least 100 times 1 minus alpha % confident. So that's looking at your experiment-wise error. So let's look at an example here. We've got utility usage that's compared for a random sample of 5 homes from each of 4 different regions in the U.S., Northwest, South, East, and Midwest. We want to order the means. So the summary statistics are here, the region, South, East, Midwest, Northwest, and then the sample mean utility usage for each region. And then we performed an ANOVA to see, which of these, to see if there's a statistically significant difference in between those means. So this ANOVA had a significance of 0.0001 actually. So that's our p-value, and it's less than 0.0001. So that tells us that there is a difference. There is a statistically significant difference. But again, it doesn't tell us which means differ, which regions have statistically significant differences and which don't. It just tells us there's at least one pair that has a difference. So we ran a Tukey test here because all of our samples are the same size. And that generated this multiple comparison table. So we compared region I to region J, so south to northwest. The mean difference, so the difference between the means, I minus J in this case was -1. Significance was 1, so that's the p-value there in that column. And then the 95% confidence interval for the difference goes from -90 to +88. And then we repeated that for all the other comparisons. Well, notice that some of this data is repeat data. So for example, south compared to northwest is equivalent to northwest compared to south. Notice that the values here are just negatives of each other. So here we had -90, +88. Here we had -88, +90. Okay, it's just switching the order. So we don't need all of these repeated comparisons. So here are the comparisons that are not repeats. So south to northwest, east to northwest, midwest northwest, east south, midwest south, and east midwest. So we're comparing all of those pairs of means. So there's 6 different distinct pairs. And then here are the confidence intervals. So I brought down, these are the bold, brought down the bold comparisons and their confidence intervals, and that's left minus right. And then we want to draw a conclusion of, are they significantly different or not? Well, if the interval contains, if the 95% confidence interval contains 0, then we cannot say that they are statistically different. So between the South and the Northwest, that confidence interval contains 0. So that's saying that the population mean for the South statistically is equal to the population mean for the Northwest. And then when we compare East and Northwest here, we get 2 positive values. So 0 is not in that interval. So the whole 95% confidence interval is greater than 0. So that's going to tell us that the difference East minus Northwest is greater than 0. So that only happens if the mean for the East is greater than the mean for the Northwest. So that difference greater than 0. And that is statistically significant. Between Northwest and Midwest here, the interval contains 0. So that's telling us that those population means are not statistically different. So the mean for the Northwest would equal the mean for the Midwest. And then East to South, this one is positive. So this difference is positive, so that means that the first mean is bigger than the second. So the mean for the East is also greater than the mean for the South. And then the next pair, confidence interval, contains 0. So again, those means are not statistically different. So the mean for Midwest is equal to the mean for South. And then between East and Midwest, that difference, the 95% confidence interval, is positive. So that means the difference between the means is positive, so the first mean is bigger than the second. So the mean for the East is also statistically significantly larger than the mean for the Midwest. So now we can make a summary diagram that compares the means for the different regions here. So we'll list them from smallest to largest. So our smallest sample mean here was the South, and then it was the Northwest, and then the Midwest, and then the East. So we'll list those in order from left to right. So that's going to be South, Northwest, and then Midwest, and then East. And then what we're seeing here is that South is statistically the same as Northwest. So these two are the same. So we put a bar above those to indicate that there's no statistically significant difference. So this bar is indicating no significant difference. So even though the sample mean for the Northwest is a little larger than the sample mean for the South, it's not statistically significant. So now the East is statistically significantly greater than the Northwest. So the East is to the right of the Northwest, and we're not going to include that in the bar. However, Midwest and Northwest, those statistically are the same, so we'll extend this bar to include Northwest and Midwest. So now all three of these should be statistically the same. And if we look down here, we see, oh yeah, South and Midwest statistically are the same. But East is greater than Northwest, so East is to the right of Northwest. East is greater than South, so East is to the right of South. And East is greater than Midwest, so East is to the right of Midwest, and it's not included in the bar. So this essentially is saying that statistically, mean for the South is equal to mean for the Northwest is equal to mean for the Midwest and all of those are less than the mean for the east. So that's what that diagram means.